Hi, I'm Mark from embeddedpro. This is the third video in my series investigating the ARM Cortex-M33 core. I'm using the LPC55S69 microcontroller from NXP, and in this video I'm going to show you how to use the pin multiplexing tool inside MCUXpresso IDE to configure a new project. We'll see how to create a new project inside MCUXpresso IDE and also how to add drivers from the SDK. It's going to be a simple new example, reading the switches on the LPC55S69 EVK and driving the 3-color LED with PWM to control its brightness. But first, let's consider why we need a pin configuration tool. In this new project, we want to control the brightness of the green LED on the evaluation kit. So first of all, we need to know which GPIO pin that green LED is connected to. I can get that from the schematic for the evaluation board. So let me head on over to nxp.com and we'll download the schematic. I know that the board name is LPC55S69 EVK. And here I can see the documentation and software for the board, and I want the schematic. Scrolling down the list here, I can see the evaluation board schematic, and with this padlock symbol here, I can see that I'll need to log in to be able to download that schematic. So I'm being asked to log in. Let me sign in with my username. And the board schematic should just download automatically. There it goes. So let me open that. And I think that the I/O pins are on the third page from checking earlier on today. So look, here we are. We've got the green LED, and this is connected to a pin named LEDG. That's a schematic symbol on the schematic. Let me find out what pin that's connected to. LEDG. I can see it here. It's very small actually on the screen, but LEDG is connected to pad or pin number 9, and it's a function called PIO1_7. We'll need that in a moment when we look in the user guide for the microcontroller. So next I need the user manual or the user guide for the microcontroller. So let's go back to the page, and we know the microcontroller is called LPC55S69. So let's go find the product page for that. It's this part just here, and let me go to the product summary where I can find the documentation. On this page, this is the product page for the microcontroller. We can see all of the information about the part, including software and documentation. What I'm looking for right now is the user guide, and that's just here. It's currently revision 1.3, and let me download that to my desktop. Well, here I am with the user manual for the microcontroller open, and if you remember, we're looking for GPIO port IO1 pin 7. Let me search for that. And we're open here on page 294 with some information about the type of that port. I can see that it's a D type, a digital port. Let's find out more about that. And here's a definition for a port D IO pin. We can see that it's got a number of different function settings, and these are listed in table 310. In table 310, it's listing all of the GPIO pins and the functions that those pins can implement. And there's a very large multiplexing going on here. So down in port 1 pin 7, I can see that this GPIO pin can be an IO, it can be a flex timer, it can be D1 for the SD card 0, can be a match for the timer, and it can be a general purpose input for the state configurable timer. We want to control this pin with PWM, and therefore it needs to be a timer output. So I'm going to need to make sure that I multiplex port 1 pin 7 to connect internal to the microcontroller to the timer. While we have all the documentation open, let me just look for the input pin. There's a switch on the evaluation kit labeled user, and I'm going to use that to generate an interrupt into my project. User switch is also switch number 3, is switch 3, and I can see that the output of the switch is connected to port IO1 pad 9. Back in the user manual, I can see that port 1 pin or pad 9 can be a GPIO, can be a flex timer clock, and some other functions. In our example, we want it to be an input and also connected to the interrupt capability on the microcontroller. Okay, well, let's now turn to MCUXpresso and start to create our project. Well, I'm now ready to create my new project in MCUXpresso, and like many of these examples, I am going to be using the Quick Start panel where all of the frequent shortcuts can be found. So first of all, let me create a new project, and this will open up the new project wizard. It's asking me for which board I would like to create my project for, and I'm going to create it for the LPC55S69. Here's a picture of the board. Let me click on that. And next. In this screen is asking me to configure the project. Let me give it a name first of all. I shall call it LPC55S69 PWM Example. I can leave the defaults, the package, the core 0 as default, but I want to add some drivers from the SDK. And I mentioned earlier on that I want to use the C timer, so I will add support for the C timer. And I also need the pin interrupt function. So this is the pint driver just here. I can select that. And now I'm done. I can finish, and MCUXpresso IDE will create my new project. Here's a project it's just created, LPC55S69 PWM Example, and it's opened the C source module .c in the window here. But as you remember, we want to use the pin configuration tool to set up the I/O pins for the microcontroller. I do that by selecting the project and then using this config tools drop down to select the pin tool. And this opens up in a new perspective in Eclipse where I can start to configure the project. The pins tool needs to be online the first time that you use it to download the latest database. That's now happened, and I'm ready to configure the pins. It's a very complex looking interface, but when we know what pins we want to configure, it can be very easy. I want to configure the two pins that we looked at earlier, PIO1 pin 7 and PIO1 pin 9. Let me find them first of all. So PIO1 7, here it is. It's pin 9 on the microcontroller. And I clicked on the pin name here, and the pins tool has proposed all of the possible functions for that particular pin. We know from the user manual that we want it to be the CTimer2 match 2 function. So I select it here, it's gone green, and down below here you can see it's gone yellow, and I'm done now. The pins tool will generate code that will configure that particular GPIO pin to be the ctimer2 match2 function. The next one I want to configure is pin 9. Well, it's PIO1 pin 9, channel 9. Here it is. This is on pin 10 of the microcontroller. And again, it's proposing all of the possible functions for that pin. I want it to be a GPIO input, so I can look down my list and look for that input capability. And here it is. PIO1, pin 9, and I want it connected to the pint module channel 0. Okay, that's done. From this diagram here, we can see that we've routed two particular I/O pins to their functions. Pin 9 of the microcontroller is a ctimer2, and pin 10 is the PIO1_9 function. So this is a general purpose I/O pin. That's all of my configuration done with the pins tool, and now I can update the code in this button here. It's going to kind of overwrite some of the C source modules that are already available in the project with these latest settings. That's all okay. The tool has now generated the code to configure the I/O pins, and the code that it generated is up here in the board folder, and it's pinmux.c. I've opened it here in the browser, and I can see that we've configured port 1 pin 9 to have its alternate 0 function. That's a GPIO function. For the timer output, this is port IO1 pin 7, and we can see that it's been configured for the alternate function number 3, which is the ctimer2 match2. And if I reopen the user manual, we can see that port 1 pin 7 ctimer2 match2 is indeed function number 3. Back into MCUXpresso. In this project, I'd like to vary the brightness of the LED by using PWM from the ctimer. But I'd also like to change the brightness every 10 milliseconds. So I'm going to add a multi-rate timer interrupt to my code, which is going to be fired every 10 milliseconds, and I'll use that to vary the brightness. So I need to add the multi-rate timer and another driver called the input mux to my project. I'll use the manage SDK components to add these two drivers. And that's this little gift box icon just here. If I click on that, it opens up the manage SDK components dialog, and I want to select two drivers to add. I'd like to add the input mux driver, and I'd like to add the multi-rate timer driver. I just select them with the checkbox, and over here I can select OK. MCUXpresso confirms that I want to update some source modules, which I do. Yes. And it sets about adding the new software to my project. I can confirm what it's done by looking in this drivers group just here, and I can see some new drivers. The multi-rate timer.c and multi-rate timer.h, as well as the input mux.c and input mux.h. And in case you're wondering, FSL stands for Free Software Library. We have one other item of setup to do. We're using the ctimer to generate PWM, and we need to let the ctimer know what clock source to use. The microcontroller runs at 96 MHz, so let's use the 96 MHz clock to drive the ctimer. We can configure the ctimer with the config tools. I've selected the project and let me open the clocks config tool. This will show me a clock tree for the whole of the chip. And we can see here that the system clock for the microcontroller is running at 96 megahertz. And tracing back, we can see that through some multiplexers going to the fast, free-running, high-frequency internal clock. That's a 96 megahertz internal clock. We want to configure the C timer to run from that clock. So I can search for that timer in this window here. And what I'm looking for is the C timer clock. And we're going to use C timer 2. We can see the multiplexer for the C timer clock. The C timer clock here is in blue. And we see that it's inactive, but it can be connected to any of these internal clock sources. Well, I select the multiplexer. It goes darker grey, and then I can select the clock that I want to use for the C timer, and I'm going to pick the free running 96 megahertz clock. What we see here is it goes blue. The C timer will be running now at 96 megahertz. Well, just like before, I need to generate the configuration code, and I can do that by updating the code for the project. It tells me what files it will change. Okay. And now we've got source code that will configure the C timer to run at 96 megahertz. We now need to write some software. Well, this is not a programming class, so I'm going to share with you all of the source code that's necessary for this project, and you can cut and paste it. I've provided a file, and it's called LPC55S69 PWM Example.txt. We can open that file and copy all of the code from this file, and then just paste it into our main module. So I'm going to copy or select all of this code and delete it and paste in the code that I've just written. Very briefly, in main, the code will configure the board, configure the printf, configures the programmable interrupt on the user pin. It configures the multi-rate timer for a 10 millisecond tick. And lastly, configures the C timer for a 20 kilohertz PWM. All of the example is interrupt driven, and so there is an interrupt service routine for the pin interrupt. This just printfs that it's received an interrupt and toggles this mask LED. There's a C timer interrupt that just updates the periodic PWM. And there's a multi-rate timer 10 millisecond tick. We get into this function every 10 milliseconds. We look to see if we're increasing the brightness or decreasing the brightness, or if the brightness is masked by the button. And then it updates the C timer PWM rates. So that really is our project. This will compile. So we select the project and then build it. We see that the code is built, no warnings or errors. And now we can download it to the development board by running a debug session. Now I have my LPC55S69 EVK plugged in via USB, and we can run a debug session. MCUXpresso makes a probe discovery, and it finds a LPC Link 2 probe connected. That's the SimSysDAP compatible probe that's on the evaluation kit. We select OK, and it will now go off and make a core discovery. And now it finds the two cores that are in this microcontroller, core 0 and core 1. We'll be using the master core, core 0, So let's say OK. And MCUXpresso IDE starts a debug session and programs the flash memory with our code. The code's now run and it's stopped in the first line of main. And we can just run the code with the debugger with the resume button F8. The code runs and we can see the message printing out into the console window. It's the NXP Blinky message. We started the timer and started the C timer. The code's now waiting for an interrupt from us. So if I press the user button, we'll see that the interrupt service routine has been called. It's printed that it's detected the interrupt, and the LED now is on a constant dim setting and will remain so until I push the user button again. So let's do that. It's another pin interrupt and the LED is starting to fade up and down in the green color from maximum brightness to minimum brightness. We'll stop the debugger and return back to main. The code has stopped, but it's actually still running on the evaluation board because it's running in Flash now without the debugger needing to be intrusive. Well, that's all we're going to do today. I'll finish the project just here by closing it. Back to our tidied up workspace. I just showed you how to create a new project in MCUXpresso IDE and to use the SDK components to read the switches and control the brightness of the LEDs on the LPC55S69 EVK. To do this, we use the pins configuration tool inside MCUXpresso IDE. I'm sure that you'll be able to do this. Let me know that it worked by leaving a comment below. And if you enjoy these videos, then please subscribe to my channel, like this video, and share it with your friends. Thanks for watching, and see you next time when I'll show you the clocks and peripheral configuration tool inside MCUXpresso IDE. Bye.